Good day, I am AMAIA Girl B. PEDROSA of BSECE 3A and I will demonstrate a unique 12 LED light display sequence using Arduino. This project uses 12 uniform LEDs, 12 resistors, 1 tact switch, a breadboard, jumper wire, and an Arduino board. All LEDs are arranged in a straight line on a breadboard placed close together. The sequence is controlled by a single tact switch. When pressed, the LED sequence runs, and when released, it pauses and freezes the current LED states. This simple setup allows us to create a visually complex and unique pattern using only one switch. So here's how the circuit is set up. Each of the 12 LEDs is connected to Arduino pins 1 through 12 with a 220 ohms resistor connected from the LED's cathode to ground. The tact switch is connected to pin 13 and we uses Arduino's internal pull-up resistor so that the pins read high when the switch is not pressed and low when it is pressed. These setups ensure that pressing the switch triggers the LED patterns while releasing it pauses display. Using configuration, we can control the sequence with one simple button and maintain the current state of the LEDs when the button is released. So in this pattern, one LED moves across the row from left to right, while a mirror LED moves from right to left. Occasionally, a random LED lights up to add predictability. The combination of waves, mirrored ends, and random jumps create a visually engaging sequence. If the switch is released, the LED freezes in their current state, and pressing the switch again resumes the sequence exactly where it left off. This ensures an interactive and dynamic display. So now I will explain the Arduino code line by line. So this line defines a constant number LEDs which stores the total number of LEDs we are using. In this project, there are 12 LEDs, so this number helps the code know how many LEDs to control. Next, here we create an array called LED pins that stores the Arduino pin numbers for each LED. This makes it easy to control all LEDs in a loop instead of writing separate commands for each one. Next, this defines the Arduino pins connected to the tact switch. We will use this pin to detect when the switch is pressed or released. And then, this creates an array called LED state to store the current state of each LED. Each element is 0 if the LED is off or 1 if the LED is on. This helps us pause and resume the sequence. The step variable keeps track of which step of the LED sequence we are currently on. It is incremented each time the pattern updates. So for this group, the void setup, the setup function runs 1 when the Arduino is powered on. For this line, we start a loop to initialize all LED pins. Next, sets each LED pins as an output so we can turn it on or off. And then, ensures all LED pins start off. And for this, configures the switch pins as an input with a pull-up resistor so it reads high when it's not pressed. For the last line, seeds the random number generator using a floating analog input to create different random LED jumps each run. Next, for this group, for the void loop, this function runs repeatedly after setup. Next line, checks if the switch is pressed. Low means pressed because of the pull-up configuration. For the last line, if the switch is pressed, we call the function that runs our LED sequence. If the switch is not pressed, the code does nothing, so the LEDs freeze at their current state. For this group, the loop clears all LEDs in the LED state array at the start of each setup, so we can calculate which LED turned on this new setup. For this group, for the first line, it calculates which LEDs on the left side should light up. It loops back to the start when it reaches the end. For the second line, it calculates the mirrored LED on the right side. For the third line, it turns on the left LED, and for the last line, it turns on the mirrored LEDs. This creates a shifting wave that moves from both ends towards the center. So for this group, for the first line, it gives a 1 in 3 chance for a random jump. For the second line, it chooses a random LED to light, and for the last line, it turns on the random LED. And then for this group, it updates the physical LEDs to match the LED state array, which light up the LED we calculated for this step. And for the last group, for the first line, it moves the pattern to the next step, and for the last line, it pauses 120 milliseconds between steps to control the speed of the pattern. The pattern moves smoothly across the LED, which mirrors and random jumps, and pauses automatically if the switch is released. So in conclusion, this project demonstrates a unique LED display using only a single tact switch and simple Arduino code. Despite its simplicity, the display looks complex and engaging due to the shifting wave, mirrored pulses, and random jump. Thank you for watching.